reminder, guys, this will be this is a commercial building. It's not a residential building, so all the rules of residential will not apply to it. I want to remind you guys that this is how we're going to design this building. If you look at the design, you need to understand how the design of this building is going to be. I should do that one more. So the riser, I would like you guys, so it makes more sense when we draw the riser very quick here. Let me just open this file. You're going to have your riser, so you know what we're trying to size here. And you might have to sketch this one because you guys will be draw. So you have this one handy for you. Okay. Okay, so here's what we're trying to achieve in a second, or size. Very quick, I'm going to sketch you a riser for you. So what you're trying, when you do the riser, here's my building, guys. This is inside. This is outside. What do you call it? We call it the riser. So what we would like to see is first you're going to have a generator, gen. You're going to have a transformer, XFR. You're going to have a meter cabinet, CT cabinet. These are going to be outside. When you get inside the building, you're going to have an auto transfer. That's how we're going to design it. Auto transfer switch. That's going to be feeding I'm going to call this a service panel, so I can follow up with what the direction they did. Service panel. Right next to it, it's going to be my lighting panel, and right next to it, it's going to be my receptacle panel. Could you please sketch this one? That's how your riser is going to look like I said. This is underground, inside and out. Any comments, guys, about this? Any comments about how your riser? Could you please sketch them? Like I said, that's how your riser is going to look like. So when you come, then you're going to come from the generator, from the transformer, you're going to go underground into the CT. From the CT, you're going to go underground into the auto transfer switch. From the auto transfer switch, you're also going to get underground to the generator. So you're going to take a feeder from the generator, the transformer, to the auto transfer switch. Auto transfer switch will select which power is available, and it's going to dump the power into the meter, into the main panel. From the main panel, you will be going into the first to the lighting panel and second to the receptacle panel. This is how the power system in this commercial building is going to be distributed. That's your riser. Cool? Now your job today will be to size the following. We're going to be sizing number 1, the service panel, number 2, the lighting panel, and number 3, the receptacle panel. The auto transfer switch, guys, will match the service panel. Any comments, guys? Any questions? Any comments? Any questions? Karen, does it make sense? Yes? No? Adam? So when I told you guys you're going to draw and we're going to design a riser, that's what we're looking for. That's our riser that's going to be there. Okay, so the sheet that you guys are having, it's going to size the following. It's going to size the service panel, lighting panel, receptacle panel, auto transfer switch will follow the main panel. The generator and the CT cabinet will size them later. So that's what we're trying to size. Everybody can see the service panel, lighting, and receptacle panel. Okay, let's go to the first thing. When you guys like we did in the commercial building, oops, let me get one, delete that. These are step 1 through step 6.5. These are your steps. They will size the receptacles and the lights and the equipment. Step 1, guys, it's a receptacle load, non-continuous. It's from 220.14i in the NEC code book. I need to see this. When I need to see this information. If you do a load calculation without typing the 22 by by 14i, I would not accept your load calc. Might as well just don't submit it. For receptacle, guys, the code says you take the number of receptacles and you multiply. Here's a number. The 219 is a number given to you just to play with. Your receptacle number will depend upon the design. For the time being, because we don't know how many receptacles we have, I want you to stick the 119. You multiply, each one of these 119 will be 180 volt amp. When you multiply them, do you guys see the math? The math is you take the 219 number of receptacle, multiply it by 180. Okay? Right underneath them, a quad, a 4 outlet receptacle, that's the quad. Double receptacles. Each one of them is assigned a 90. So you're going to take basically, I want to bring to your attention the 4 here. Can you guys see the 4 here in the math? So if you have a quad, every one of them will count as 90. So you take, a quad has 4 outlets, each one of them 90. So 4 times, so what your math would be 90 times 1 times 4. Did you guys hear me about this? And that will get you the 360. You're going to add them up. Any question, guys, about the receptacle load in this panel? Any question about the receptacle load in this panel? I want to bring to your attention, guys, right here. You're going to be using this calculation to find the service panel neutral, the receptacle panel neutral, lighting panel neutral. Did you guys see what this panel is? It will size the 3 panels right for you from the get-go. Adam, does it make sense? So SP, service panel, SP and the neutral for it. RP, receptacle panel, the phases, the N is the neutral for it. LP, the lighting panel phases, and the N is the neutral. Who's the neutral? Typically smaller than the others. Cool? All right, so you're going to see me pulling information, putting it under each one of them. Okay, so you're going to start. Any question, guys, about calculating the receptacles? The receptacles in a commercial building are calculated at 180 volt amp per square foot. 180 amp per square foot. So, you know, if you go to the NEC code book, 220.14, what did we say? 220.14, where am I here, Chad? Okay, so 220. Okay, here's 14. Okay, PC all the way. B, C, D, E, F, G, H, I. Here you go. I think it's right in here. There you go. Can you guys see where it says receptacle outlet, except as covered by this receptacle outlet shall be calculated at not less than 180 volt amp. That's where this is coming from. Any question, guys, about where this information is coming from, the NEC code book? From 220.14i. Cool? Okay. So here's my receptacles. So the first step is going to be, step number 1 is finding the volt amp for my receptacles. How many receptacles you're going to have in this building? You're going to go, can you guys see when you go to the spec? Here's my spec. If you guys go to the receptacle, design power, so Adam, it says receiving room 120, 1 receptacle for every 1,000 square foot, standard. So that's where you're going to get the number of receptacles. You can right now calculate the number of receptacles without designing it. Did you guys hear me? Karen, do you know where to find the number of receptacles? Right from 1.8. Matt, does it make sense? Adam, that's how the actual number of receptacles, you can find it directly from here before you start laying out your receptacles. Cool? So receiving room 120, so you can get a guess. It might change later on slightly, but not a whole lot though. Okay, that's the number of receptacles. Any question about calculating the number of receptacles? 1.1 is said fixed multi-out assembly non-continuous. 220.14h, guys, it will tell you, you take for every 5 feet, if it's for every 5 feet. If it's not simultaneously used, you take 180. If it's simultaneously used, you take it for 100. For every 1 foot, for 1 foot, you take 180. You guys see that? Everybody can see that? How you calculate them? So you come over here. Here's my, I have 50 feet of simultaneously used. Can you guys see how, look at the math. Everybody can see the math. The math is you take these two cells, the 50 multiplied by 180 divided by 5. The one underneath it is the 40 multiplied by 180 divided by nothing. Do we have a multi-outlet assembly in our building? No. Do I want you guys to put this information so to make sure the system is working? Yes. And then we're going to remove them. I just want to make sure that your sheet works. Any comments, guys, about the multi-outlet assembly? Any comments? Any questions? Then you total them. Can you guys see when it says total? You add these two together, these two steps together, and that will be the total for your receptacles. The total for your receptacles, which is the grand total. 1.2 is the grand total for 1 and 1.1. You add them up. Any comments, any questions about the receptacle load? The receptacle load for this building. Does it make sense? Adam, makes sense? Okay. Then what I'm going to bring to your attention, guys, is one more. 1.3 receptacle load demand factor. You have to apply 220.44, guys, the receptacle load demand factor. So here's how that goes. You're going to go to the NEC code 220.44. 44. There you go. So 220.44, oops, where did I go here? Right here. It says the first for non-dwelling receptacles, Karen, the first 10K, you leave them alone. Anything higher than 10K, you need to cut them by 50% from the NEC code book. Does it make sense? The first, after you add all these receptacles together, you're going to cut the first 10%, leave them alone. The remainder will be cut by 50%. Can I have a thumbs up that we fully understand this one, guys? Adam, start with Adam. Yes, no? Matt, Kieran? Take all your receptacles, cut the first 10, leave them alone. The rest is 50. Brian? Makes sense? Okay. So that's what your step is here. So here's what we do it. The first 10, leave them alone. The remainder, which is 3878. Can you guys see the math? Look at the math that they're using here. Cut it by 50%, and that will give you the total. Any comments, any questions about demanding the receptacles? Any comments, any questions, guys, about demanding the receptacles? Demanding the receptacles? Yes, no? No? Is it too much, guys? Is that too much? Serious? Is that too much? Imagine if I ask you to come up with all this one without a map, without a sheet. Okay. For the office building, only for office building, Matt, the code says you need to compare the office building after you do the calculation. They allow you a 1 volt ampere square foot for the office building. So if you guys look at step number 1.4, it says for office building 220.14K, 1 volt ampere square foot. Here's 1 volt ampere square foot. Give you 10,000 square feet. Can you guys see that? 10,000 square feet, everybody? Then the last step for this is you need to choose 1.5. Choose the largest of line 1.3 and 1.4, the actual versus the calculated. So you are to use the largest between the actual and the calculated. So, and if you guys look at this, how this math is, you're going to pick the largest of a 10,000 or the actual receptacles after you demand them. Any comments, any questions, guys, about the receptacles? Would you guys rather type it in first before I move on? Serious. Go through the typing process. You go through it and then I'll walk you through it. Yes, no? Does it sound like Greek? Are the steps clear? How to follow the steps? So first you demand all your receptacles. Well, I don't want to have, yeah. So you're going to add all your receptacles, and then you're going to apply the demand factor for them right here. And then you're going to compare this number with the actual number with what the code allows you, which is 10,000. And that will be the number that you're going to carry, 29,000.390 kilovolt amp. Now this is where I would like you guys to pay a little bit of attention. Can you guys see how I'm carrying this number here is going to be under the neutral. The neutral will see this, and also the receptacle panel will see it because it's receptacles, and the receptacle neutral will see it. Now, Karen, the lighting panel will not see the receptacle load. Anybody knows why the lighting panel would not see the receptacle load? Because the receptacle load is going to be fed from the receptacle panel. Everybody knows why there are zeros here? These two have zeros on them. So these will be only seen by the lighting panel, not the receptacle. The receptacle panel, not the lighting panel. Okay. Any comments, guys? Any questions up to the receptacle load? Receptacle load, can I have thumbs up, thumbs down in between? No? Good. So this load is your receptacle load. It will be seen by the main panel, and it's neutral by the receptacle panel, and it's neutral, and it will not be seen by the lighting panel, or it's neutral, right? Because it's a receptacle load. Okay, now another load, guys. There's unknown receptacles. 1.6 is unknown receptacles. Now, Matt, we have a 10,000 square foot addition to the building. We need to accommodate for the receptacle for it. I don't know how many receptacle will be in it, so I can't compare. So what you need to do for this one, guys, is we take the 5,000. Can you guys see that right here? Here's the 5,000 multiplied by 1 volt amp, because that's what the code says for office building, if you don't know what the receptacle is. And that will get you a 5K for the new addition accounted for the receptacle. And then you add them to your 39 and your over. And can you guys see how we add them here? This 5K will be seen by the receptacles. Everybody knows where the 5K came to be. These are receptacle for the new addition of a building. That's it. That's the load for the receptacles. I can't emphasize, guys. First, you do the number of receptacles multiplied by 180. Add them up. Demand them. First 10, leave them alone. Higher than 10, cut by half, add them up. Then you have to compare them with the 1 volt ampere square foot from the NEC code book. Okay, so so now I have the receptacle load on both my receptacle panel, and it's neutral, and my main panel, and it's neutral. Okay, let's go to the light. If you guys go to the lighting panel, now step 2, can you guys, step 1, everything for step 1 was receptacle. Step 2, general lighting load, table 220.12. From 220.12, guys, for a commercial building, let's go directly to a commercial building. Okay, so here's, let me see here, 100. Okay, 220.12, here's 220.12 right here. Now, Karen, when you have an office building, can you guys see where the office building is right here? Office building. It says for office building 2.5 volt amp per square foot. 2.5 volt amp per square foot. Okay, that's for an office building. So, light. So here you go. So and then
where the actual number of general purpose outlet is unknown. Okay, we got the receptacle. Here you go, the general lighting. Multiply. So here's what we did, guys. We took the 3.5. Everybody knows where the 3.5 came to be from the code. Multiply it by the 10,000 square foot of a building, get you 35K. 35,000 volt amp for lights. Okay, that's easy. Then actual. You guys are supposed to do the actual. Here's how the actual is. You're going to calculate your actual lighting load. Did you guys hear me? You're going to have a table like this that calculates your actual load after you design the light for the building. And you're going to compare the actual light to the code and choose the largest. You don't know the actual yet. Do we know what the lights for the actual? By the way, this file here, Adam, can you see this file? That's also on the network. That's also on the network for you. That's fine. So you're going to calculate your fixture A through T, if any, add them all up, the volt amp from the manufacturer, compare them to the 3.5 volt amp per square foot, and choose the largest. Okay? So that's what we're going to do. Let's go back here. So the actual load, here's my actual load. Can you guys see that? This is where everybody knows where this came to be. This is coming from this number here. Here's my actual load. You compare that, then you choose the largest. You pick the largest of actual or design, which is changing now, and you got yourself 35,000 volt amp because it's the largest for the lights. Now for the future addition, can you guys see that? Then I go general lighting load, got the largest. This is for the future. 2.3 is for the future edition, because the future edition is 5,000. I need to accommodate for this. Do I know what the lights for the future edition would be? No. So I just stick with that 5. Okay, here's my 5. Okay, the 5 square foot. Okay, so that's that load here, the 17.5 is coming for 3.5 times the 5,000. Okay. Then you go to track lights, and all these guys are referred in the NEC code book. You have a track lights. For a track lights is 150 volt amp for every 2 feet or fraction thereof of the track light. Okay. I have one track light. I'm going to multiply, 30 feet of track lights, multiply by 150. That will get you this amount. And you're going to cut it by 0.5 because it says for every 2 feet. Can you guys see that? For every 2 feet. So you have to cut the math when you do the math here. Everybody can see where the math is here? Where it says 0.5. Why did I multiply it by 0.5? Because every 2 feet. Okay, so got your track lights accounted for. Then right underneath it, track lights, we got them. 2.5 sign and outlet. The code says that you guys have to have a 1200 volt amp for sign. Okay, here's one sign, 1200 amp. That's what you get. That's easy, straightforward from the code. Show window. For show window, include 200 volt amp for every linear foot measured horizontally for show windows. Okay, I assume that there will be one show window, 10 show windows here. 10 feet of show windows, multiply by this. So that will give you for show windows. All lights, right? Then parking lot. Can you guys see the parking lot light? Parking lot light is actual. I don't know. For parking lot, I do the actual. So here's my actual. I use the 1,000 volt amp for the parking lot right now. You will change this one when you finish your project. 10,000. The last thing, guys, is 2.8. It will tell you, oh, by the way, all these are lighting loads and assumed continuous. So do me a favor, go increase them by 25%. Did you guys hear me? Because they're all continuous loads. So what you do here is you add them all up. Can you guys see how we're adding all the lights up? Multiply them by 1.25, and that's what you get. That's what you get when you multiply it by 1.25. Then that's 73.7 or 73688. Can you guys see that number here? That's the demand for the light for this building. By the way, these numbers are examples only. Your numbers will be, if you follow them, you're good up to 70%. You might have to tweak them later on, guys. But we'll give you at least the math up and running. So that 73,688, this will be the lighting load. I want to bring to attention, Matt, this will be also seen by the neutral because lights are connected to line to neutral. So that's why I carried it here. It will be 0 on the receptacle panel, Brian, because these lights, they're not going to be fit for receptacle panel, Chad. How about the neutral of the receptacle panel? Of course. And they will be seen by the lighting panel. They will be seen by the lighting panel. Any comments, any question, guys, about allocating the lighting load to the receptacle panel, the lighting panel, and the main panel? Does it make sense? No? Too much? You guys are designers now. We finished residential. It's really nothing. If you follow, you know, the hardest thing, guys, is to come up with these from an NEC code book, to build it yourself. I mean, go all this. The nice thing, what we've done for you in the past is, can you guys see all these references of the NEC code book is there? Now, imagine if I don't give you these references and say, go design a load calculation for commercial building without these references. Would you be able to make it, Adam, without the references? It'll be hard. Okay, so we got the continuous load. That's your light. Now, switching to step number 3, that kitchen equipment, 220.55, it says multiply 3 or more by the demand from this. For kitchen equipment, I only have, I think, a fridge, dishwasher. Multiply by 20, get you this. This is just for kitchen equipment, not a whole lot. And it's all fed from the receptacle panel and the main panel. Moving into the heating, cooling. That's what we did, guys, in the commercial building too. Here's my heating, cooling. Heating. NEC 424 talks about heating. The heating will be calculated 100%. So if you go here, here's the heaters. Oops. I have a heating units, cabinet unit heaters and boilers and so forth. These are directly taken from our project. The total load for the heating is going to be almost 3K. Then cooling units. The cooling units, guys, are 2 condensing units. These numbers are coming from your full load current at 288. So cool condensing unit 1 and 2, Matt, are coming directly from the NEC code book. From the specification. And at the end, you are step number 4.5, non-coincident 4.2, you are to choose the largest of the cool or the heat. So here's the largest of the cool of the heat. Can you guys see that? Where does these numbers came to be? All these are directly from your project. So you need to go right here to the mechanical equipment. Here's your mechanical equipment, and you're going to find the condensing unit. Here's your condensing unit, and here's the full load amp for the condensing unit, and condensing unit, the full load amp for the condensing unit. All this information is taken directly from the sheets. Horizontal unit heaters, here's the information about the horizontal unit heaters and so forth. These are directly coming from here. Any comments, guys? Any questions? Comments, questions? So that's your heating and cooling units. Now these heating and cooling units, they will be seen only by, can you guys see that? The heating is going to be only seen by the main panel. Make sense, Adam? It will be seen by the main panel. They will not be fed from the receptacle panel or the lighting panel. Are you okay? Did I lose you? No? Okay. So they will only be used by the receptacle, the main panel. This little load here, guys, this little load here, the only thing that will be seen by the neutral is only the neutral load, which is anything that's 120. That's why this number is here. It's taking this number because it's 120. Okay, so moving on into, and as you go through, feel free to ask me, guys. I know there's a lot of stuff, but feel free to ask. I mean, not a big deal. So we got the non-coincidental load file server. Here's my file server, guys. This is my file server is 100%. It's all going to be fed directly from the main panel load. Motor load, can you guys see 4.4 is my motor load? My motor load, Matt, all these are coming from the motors, the specification in our project. All the full load amp, all the voltages, they add them up. They add 25% to the largest motor. Remember that we added 25% to the largest motor? Add them up. We're going to do the same thing for the neutral, guys, except for the neutral, anything that 208, like these equipments here, it's going to be 0. Anything that 120, anything single phase will be 0. I'm sorry. For the neutral, anything 208 3 phase will be 0. And the only thing that's going to count is the 120. Can you guys see that? These under the neutral, only the 120 will count. Exactly like we did for the residential. Add them up. They're all going to be fed only from the main panel, these equipments. And service equipment and sub panel. Okay, so that's basically it. And then the last thing you need to do is add them up. I don't know if you guys can see here. Here's all my total in the main panel and the neutral, the receptacle panel and the neutral, the lighting panel and the neutral. Divide them by 208. Can you guys see I'm dividing by 208, 1.73. That's the amps, that's the amps, that's the amps for the neutral and the current. The size of the panel is going to be 600 amp here, 125 amp here, and 225 amp here. The size of the conductors, they're already sized here for you, phases and neutrals. And again, these are, yours will be different. Be aware. I want you guys to do the calculation. And then at the end, we size the grounding electrode conductor and the equipment grounding conductor. These will be grounding electrode conductor and equipment grounding conductor as well as the conduit. For the feeders, we're using EMT. For the service, we're using PVC Schedule 80. Any comments, guys? Any questions? Any comments? Any questions? So do me a favor. For the rest of the day, take this, go build it, walk through it. When you come to a spot like you did, Adam, in the past, say, Chad, walk me through this one. Cool? Just to summarize, guys, every time you have a commercial building or residential building or whatever building, you're going to have a load calculation for it. You're going to start with the receptacle, demand them, light, demand them, light we increase them. Then the heating and cooling, choose the largest, and the motors, add 25% of them, add them up, divide them by the voltage, find the amp, size the panels, and size the conductors. Cool? Any comments, guys? Any questions? Now, can you assure me that this is enough information to get you up and running? Is this enough, guys, to get you work on it? This will be due next week, so if I were you, copy this one, start building it. So be ahead. I'll be around to help you. Comments, questions? As you move through it, guys, my expectation is you will go into the NDC code book and you will see where these sections are located in the NDC code book. All the section that we did. Don't forget, Karen, that you will have another tab. You guys are familiar with Excel. You must have another tab that shows exactly this. Light. These are your lights. They will be yours, guys. Use these numbers for now. Yours will be different because we're going to design a system. You have to have a design a system. Okay. Can you assure me that you know that there are two tabs in this calculation? One tab for the actual lights, and the first tab is for the whole calculation. Brian, this is the difference between a drafter and a designer. a designer, guys, you're not drafters. You know how to draft. But when you go there, when Mishad and everybody else go there, they expect you to be able to understand, do the calculations, size the system like we did, as well as drafting it. That's the best estimator, the best designer that you're going to graduate. So, any comments, guys? Any questions? Any comments? Any questions? Cool. I want to remind you, you have a PDF file of this. So grab the PDF, copy it, and start building your CAD. Please do not submit to me anything that does not have math. I mean, it would not be accepted. So, and if every step here has to be calculated. So when you go here, this number, when I click on it, I need to see math. Equal E4 by G4 multiplied. If you just type the numbers, it doesn't do me any good. Or yourself too. Cool. If you're stuck with any math function, Adam, I'll help you. Not a big deal. Any math function that doesn't make sense to you. So my expectation, guys, is to build it and get the same numbers that I got first. And we'll go from there. Comments, questions? Okay, I'll let you guys work with it. The last thing I want to do, not now, in a few, just show you how to print from Revit, and we'll achieve the goal for the day today. Thank you. Okay.